This video is going to talk about restrictions and multiplying and dividing rational expressions. So the first thing that I want to go over is how to state a restriction when we're dealing with a rational expression. A rational expression is basically anything that's in fraction form with variables on the bottom. So basically we want to make sure that our bottom is never 0 of a rational expression because that would make it undefined. Okay, so really all we're doing is restricting these bottom areas here and here so that they can't be 0. Okay, the top does not need restrictions at all. Okay, so the restriction for this would be that x cannot equal -1 because then we'll have -1 plus 1 and that creates 0 times another value. And the restriction for this is that x cannot equal 2. Okay, moving over to the second example here, if you have an x that is sitting outside a value, that x restriction would be that x cannot equal 0. Okay, and an expression where we have a value in front of the x, you're going to want to do, you're still going to switch the sign, but you're going to do this over this, so it's going to be a fraction. So this one will be, it cannot equal +3/2. Okay, so the number that's by itself over the coefficient of the x. Okay, so those are restrictions. Okay, so I want to do a first example of multiplying rational expressions. The first thing that we're going to do, usually no matter what type of rational expression we're working with, is go to each numerator and each denominator and factor or common factor as much as you can. Okay, so for instance, this fraction on the left-hand side over here doesn't actually have anything that can be factored or common factored. 3x is a single term, so single terms can never be factored or common factored either. But this, underneath here, this can be factored. So this is a trinomial, so what two things multiply to 3 and add to 4? Okay, the answer would be 3 and 1. So we're going to simplify this into x plus 3 and x plus 1. Okay, and before we continue here, we're going to make sure that we do our restrictions. Okay, remember restrictions are only the things on the bottom. So our restriction for 2x is going to be that x cannot equal 0 because 2 times 0 would make the bottom 0 in that case. Our restriction for x plus 3 is that x cannot equal -3. And our restriction for x plus 1 is that x cannot equal -1. Okay, these are all of our restrictions for this question. Even if something ends up getting canceled out, those are still restrictions, even if we don't see it in our final answer. Okay, I like to just put a bracket around binomials that are all in a numerator or all in a denominator, just to remind myself that I can't go in now and cancel separate x's like this. Okay, that's a no-no. We can only cancel this full term with another x plus 1. Okay, so I do see another x plus 1. We also have to check and make sure that 1 is on the numerator and 1 is in the denominator. So here's our 1 in the numerator and x plus 1 in the denominator. So I'm canceling out those full terms, and as long as I cancel out the full terms, that's okay. Just as a reminder as well, we can only cross cancel when we're multiplying. Okay, so you have to have a multiplication sign in between here, otherwise you're not cross canceling anything. Okay, you can cancel in an individual fraction, but not across like I just did. Okay, I'm seeing an x here and an x here. Those can be canceled. And that looks like it to me. So on the top, we're left with a 3. And on the bottom, we're left with an x plus 3. Okay, again, I can't cancel out these two 3's here. If you were in my class this semester, I would have taught you that if you're going to cancel something and it has a plus or minus right next to it, you have to stop right there. Okay, that's not allowed, so you need to make sure that you don't do that. So this is actually our final answer, along with these restrictions. Alright, this next question is a division question. I'm going to start the same way that I started the last question, and that is I'm just going to go through all of my terms here, and I'm going to factor and common factor. Okay, so in the top I'm noticing there's a common 2, so I'm going to take that 2 out. And we'll be left with x squared plus 2x minus 3. Okay, we're actually going to factor that trinomial in the next step. Put a little equal sign here. I'm going to factor out the 4 from this first denominator. Have x plus 3 left. Okay, I'm going to keep the division for now. We'll take care of that after. Okay, so on the next numerator we have a common 3 and a common x. We're left with x squared subtract 1. Okay, and I'm noticing in the bottom here that there's also a common x, so I'm going to take it out and we'll get x squared minus 6x minus 7. Okay, this isn't fully complete yet because I'm seeing a couple trinomials here and here, and I also see a difference of squares here, so all of those things still need to be factored. So looking at the top, two things that multiply to negative 3 and add to 2 are positive 3 and negative 1. Okay, this denominator is already fully factored, so we'll leave that. Okay, difference of squares. Difference of squares is going to factor into two brackets that are the same, but one is a plus and one is a minus, and it comes from square rooting the x squared and the 1. So square root of x squared is x, and the square root of 1 is 1. So I'm going to put that in those. Okay, and then the next one, what two things multiply to negative 7 and add to negative 6? That would be negative 7 and positive 1. Okay. So now that everything is fully factored, we can go and do our restrictions. So I'm just going to do up in the top corner here, I'm going to start a little list. And remember, it's only the things in the bottom that require us to do restrictions. So my restrictions would be this, this, and this. Okay, so I'm restricting all of those things with x's on the bottom. Okay, so for the first one, x plus 3, the restriction for that is negative 3. If we ever see an x by itself outside, that's a 0. Okay, for negative 7, that's going to give us a restriction of positive 7. And for positive 1, x plus 1, that's going to give us a restriction of 1. Okay, so that will be part of our answer at the end. We'll just leave that there for now. Okay, there's only one extra little thing that we need to do in our division questions that we don't do in our multiplication questions, and that is that when we're dividing two fractions, we need to flip and multiply. Okay, so I'm going to take the second fraction here, I'm going to change the division to multiplication, and I'm going to swap the numerator and the denominator. Okay, I'm making sure that I'm not canceling anything out yet at this point. Okay, we want to make sure that we don't miss anything. Alright, so we've got that flipped. We have the division changed to a multiplication. Now I need to go and make sure that all of these things are contained already in my restrictions list, and if they're not, then we're going to add them in. Okay, so for this guy right here, 3 times x, that is a restriction of 0, which we have, so that one's done. X plus 1, the restriction for that is minus 1, and we already have that in our list as well, so that's done. And x subtract 1, the restriction for that is 1, and we do not have that in our list yet, so we need to add that, so I'm going to add it into the list up at the top here. So negative 1 and also positive 1 now. Okay, now is the fun part. Now we get to go and either cancel up and down or cross cancel. Because we've now changed that to a multiplication, I'm allowed to cross cancel. Before, I would not have been allowed when I was at this step. Okay? So I'm going to cross cancel, well, let's cancel up and down first. I'll do x plus 3 and x plus 3. X and x. We'll do x plus 1 and x plus 1. X minus 1 and x minus 1. And I see that I can also reduce this 2 and this 4. So I'm going to cancel those. I'll be left with a 1 and a 2. Okay? Okay, so on the next slide here, what we're left with is an x minus 7 on the top and a 2 times a 3. So that will be over 6. So x minus 7 over 6. Okay, part of our answer is obviously also our restrictions list here, and that's why we boxed this up in this slide. So x cannot equal negative 3, 0, 7, negative 1, and 1.